The diagram shows the curve y equals the square root of x minus 3. Use the trapezium rule with 4 strips of each of width 0.5 to find an approximate value for the area of the region bounded by the curve, the x-axis, and the line x equals 5. Give your answer correct to 3 significant figures. State with a reason whether this approximation is an underestimate or an overestimate. So let's have a look at this then. We need the trapezium rule, don't we? So let's get that down. So here, the integral between a and b of y dx is approximately equal to, using the formula, is h over 2, and then it's y0 plus yn, plus 2 lots of all the values in between, isn't it? y1 plus y2 plus dot 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 plus y to the y of n minus 1, close brace, and the value of h is equal to b minus a over n. So, okay, we've got 4 strips, so n is 4, the number of strips is 4, b is going to be 5, and a is going to be 3, isn't it? So, let's start putting those numbers in then, shall we? So b is 5 and a is 3. 5 minus 3 is 2. So let's put 2 here. The number of strips is 4, so n is 4. So let's put that in as well. So h is 2 over 4 is a half, which it says here. And then we've got h over 2 in the formula here. So it's a half over 2 is a quarter. So we can replace that by a quarter then. So let's do that at the outset. And we already know that h is a half anyways. So we got a quarter of that. Now n is 4 as we said, so let's put y4 there. And then it's 2 y1, y2 and y3, isn't it? So let's put that in there. And then we've got the formula that we want to use in the form that's appropriate. So there we go. So there's our formula then. So we just need these ordinates, these y ordinates. So let's put down the x ordinates first. So in this case then, x0, x1, x2 and x3. Let's write down what these are. 4 strips, 5 ordinates, so we'll need one more, x4. There we go. Okay, so x0, we started at 3 and we went up by 0.5, didn't we, as our strip width. 3.5 then. 4, 4.5, and 5.0 will be the 5 value. This is 3.0. So now we need y0 to y4. Let's see what these are then. So it's the square root of, remember what it was? X minus 3. So it's the square root here of x. 3 minus 3 is 0. So the square root of 0 is 0. Then it's the square root of 3.5 minus 3, which is 0.5. Square root of 1, which equals 1. And this was the square root of 1.5, isn't it? 4.5 minus 3 is 1.5. And this here would be the square root of 2. Okay. Right, let's work this out then. Now I think we needed to work it out to 3 significant figures, so let's carry on then. So we can put these numbers in here. So answer is equal to 1/4, and it's going to be the first and the last y ordinates here and here. 0 plus root 2 is simply root 2 plus 2 lots of the 3 in between, isn't it? This one, and this one. So it's root of a half, 0.5, plus 1, plus root of 3 over 2. Close that bracket, and then close the brace. So let's type that in the calculator then. So it's 0.25 times bracket root 2 and then it's plus 2 times, bracket, open bracket, root of 0.5, plus 1, plus the square root of 1.5, isn't it? Close the bracket, close the brace, so 2 brackets closed, equals. Now to 3 significant figures, it's 1.82, isn't it? That's the third significant figure there, 1.82. So equals 1.82, and that is to 3 significant figures. So that's that part completed then. Right, now let's have a look at the other part. Now it asks us, state with a reason whether this is an under or overestimation. Now part 2. So essentially we've got this curve. I'll do a quick sketch of it here. And this is the value at 5. This was the value at 3. This is y equals the square root of x minus 3. And then we're doing the rectangles here, aren't we? Basically. The trapeziums, sorry. Here is what we've got for the trapezium rule. So it's an underestimation. It's an underestimation, isn't it? You can clearly see that from the sketch, simply because these trapeziums are underneath the curve. They're underneath the curve because the curve goes around like so in a convex way. So it's an underestimation because the curve is convex. The curve is convex. And the trapeziums lie inside the boundary of the curve. The boundary of the curve in each case. This is because this is due to the fact. Now let's say it more mathematically then, rather than observationally. This is due to the fact that. Okay, so what's happening here? We're going around like this. So here the gradient is steep, and then the gradient turns around like this in this convex sort of shape, so that we get all the trapeziums lying inside. But the gradient is diminishing as it goes around, doesn't it? So that's the reason. So the gradient is infinite here, and then it starts to diminish and starts to decrease all the while. So the second derivative is negative. Agreed? Because the gradient goes from a high positive, very high positive, of course, to start with, round to like gradient value 1, say at 45 degrees or something. So it continues to decrease. So due to the fact that the second derivative, d2y by dx squared, is negative. So the rate of change of the gradient is negative. And that's what we have here in the interval, in the said interval. That should suffice to say that. That's the mathematical reason, isn't it?